Hey, what's up, guys? Chung here again. So today, let's take a look at this problem here. Number 1218, longest arithmetic subsequence of given difference. Okay, another array problem here. So you're given like an array here, okay, an unsorted array. Okay, it could be either zero, like any integer basically, and another difference here. So it asks you to find the arithmetic subsequence. So what's the arithmetic subsequence? Mm, so the arithmetic subsequence means that, for example, if the difference is one, okay, basically the next number, right? So the next number in this subsequence should be equal to the previous one plus this difference. Okay, basically that's how it's example here, how he explained this, which is an arithmetic subsequence such that the difference between, okay, so this is better. So the difference between adjacent elements in the subsequence equals difference. Okay, so for example, this one, there's a 1, 2, 3, 4. So the difference is 1. So which means uh, this one should be, so the difference between each of the adjacent elements should be 1. In this case, it happens to be odd numbers, basically 1, 2, 3, 4. That's why the longest subsequence is 4. Okay. How about this one, right? So for this one, you guys, as you guys can see the difference between each number, each like adjacent element is instead of 1 is 2. That's why the output is 1. So this one tells us the minimum answer, right, for this problem is 1. Okay. Basically, no matter what's the difference here, the number itself should always count as a subsequence. Okay, and this one, yeah, and so the difference can also be a negative, which means it's going to be a decreasing number. So in this case, it's going to be a 7, 5, 3, and 1. Okay, so and they ask you to find the longest ones. Cool. And yeah, so the input length is 10 to the power of 5. Okay, this thing is like the number range is like also 10 to the power of 4. Okay, so this constraint tells us, so our algorithm should be either O log O(n) or N log n. Okay. Mm, okay, so I mean, every time when we see like this kind of problem, it first, okay, so it asks us to find the longest. Sorry, where is that? The longest, okay. And I think the first thing I may try is can we solve this with a binary search? Okay. Mm, so remember the binary search is we search the answer. Let's say we search the number k. That's the longest one. Mm, can we can we solve it, right? So the binary search, probably not, right? Because, for the binary search, your helper functions has to be either increasing or decreasing, okay? But with this one, let's say we basically, let's say if we're searching the k is the longest subsequence, okay? And then we're trying to show with this, like, k is the longest subsequence. Can we find such thing? Can we find such subsequence that has like this, the length of k, whose difference is this difference? Hmm. I mean, if we can't find it, right, it means that uh, we have to go. Okay, let me think. Hmm. I think binary search is doable, but the issue for the binary search is, for the so let's say assuming we're trying to use binary search. So basically, the helper function, what it does is with a given length, right? With a given length k, can we find a subsequence that exists in this that has the length k? Okay, so in order to find that, basically we have to loop through all the array here. Okay, we have to loop through all the array from the first one to somewhere here, right? And then since it's a subsequence, right? We have to basically for each of the element here, we will try to find if there is like a subsequence with the length k. If the first one, let's say the one doesn't have it, then we need to move to 5. And for each of the loop here, right, we have to go through all the elements, all the way from starting to the end. Then we can make sure, okay, one doesn't have a subsequence, doesn't have a k-length subsequence starting with 1. Okay, and same thing for the 5, 7, and for each one of them. So the time complexity for this, it's going to be so for the helper function itself, it's going to be a n square, right? Plus the binary search is going to be n square log n. Okay, this will definitely TLE given our constraints here. So, I mean, the binary search is definitely doable, but it will not pass, right? So, which means the binary search is not one of our options. Then what's our other options? So with this like constraints, we can certainly think about DP, right? So basically, for this problem, the DP is a little bit different because the way this DP works is instead of using like a array here, right? We're gonna use a hash table. So why is that? Because of the range of the numbers here. You know, since so basically the DP we're going to define it here is that we're gonna define like the DPI means, right? DPI means that with this number, right? Sorry, with this like number I ending, the last element is this I, and what's the length? What's the maximum length, right? Of a subsequence that ending with this number I, okay, whose the difference is 1. So that and every time when we have like a DP, so that the DPI minus 1 equals to what? Equals to the DP sorry, the 1 plus DP uh I minus difference, right? Yeah, yeah. So basically that's gonna be our like the state transition function here. So why is that? Because let's take a look at this one. So at the beginning, right? So DP1 means like 1. And also since we're storing not the index, right? Since we're storing like the numbers here, right? We're storing the number itself. And as you guys can see, the range of the number is like it's pretty big. That's why we cannot use a DP here. We cannot use a list here. Instead, we need to use a hash table to store our like DP result. So basically, every time when we have a new numbers here, we'll try to look for basically if this number uh our target number. Okay, so basically this I minus difference will be our target, right? It's gonna be the values we're trying to use. Basically, if this one it does not exist, okay, does not exist in the hash table, right? Basically, we will mm, we will store we'll store this one to the hash table with the value 1 because the number itself will always has one length, right? And then Okay. So basically, when we have one here, right? When we have one, hmm, so when we have one here, the target is dp uh, uh, 1 minus 1, which will be 0, which means the old data we're trying to use is not there. That's why we're gonna store the dp 1 equals to 1. Okay, and now we're at 2 here, so the dp2. Okay, so the dp2 we're looking for 1, right? Because we know in order to make this subsequence arithmetic for the current 2 we need a 1, and so that's why we're looking for, do we have a 1 in the hash table? Yes, we do, right? That's why we do and then we just do this 1 plus dp1, which is 2. Okay, same thing for dp3. Okay, and then 3 and then 4. Okay, and yeah, so that's that for this one. And every time when we have a new numbers, right? When we have a new numbers, I have a new DP numbers, we're trying to update our final answer. Why is that? Because the longest substring, the longest subsequence might not be at the end of the array. So so that's why we need to keep updating our final result every time when we have a DP value here. So same thing. So let's go over the example 3 here one more time. So with 1 here, right? So with 1, uh, the with 1 the what the target is 1 plus 2, which is 3, which does not exist in our hash table. That's why the dp1 is 1. So the dp1 is 1. Okay. So for 5, so the 5 is the 5 plus 2 is 7, right? It's not in the our dp hash table. So this one is 1, this one is 1. 7 is also 1, right? Because for 7 we're looking for 9. Okay. So for 8 we're looking for 10, which is not in the dp. So still 1. So but now, right? Let's say now we're at 5 here one again, right? But for 5 now it will try to look for 7 again. But okay, at this time 7 is in the hash table. Okay, that's why at this moment 5 is 2. Okay, and then when we add 3 here, we're looking for 5. 5 is also in the hash table, whose value is 2. Then the 3 has 3 here. 4 we're looking for 6. It's not in the hash table, so it's 1. 2 we're looking for 2. Sorry, for 2 we're looking for 4, right? And the 4 is in there, so 2 is 2. And 1 we're looking for 3. 3 is here, so this is 4. So in the end, the answer is 4. Cool. Yes, I think that's pretty much the thinking process, and let's try to code these things up here. So a few things here, and array, okay, and then so we're gonna have like a hash table, right? And so the hash table is the length, right? So uh, how can I name these things? So it's gonna be a mm, well, I'll just call it DP. Sorry, sorry about the naming here. I'll just call it DP. And also we need an answer here equals to 0. Okay. So now for a number, right? For number in array, okay? So the target is what? Target is this. Target is the number minus difference, right? Okay. And if target not in DP, okay, then we know, okay, this number it's a single number, right? Which means it should have the length 1. Okay. So that means DP remember it's not target. Okay, it's this number itself, right? It's number, not the target, equals to 1. Okay, else else dp number equals to if the target is in the dp, then we can simply use that, right? We use 1 plus the dp target. Okay, and then in the end we simply update that. Uh, yeah, sorry about that. It's my rice cooker. Yeah, it's lunchtime for me, so yeah, okay. Let's continue. Uh, so answer equals to max answer dot dp num. Okay, and then in the end, we simply return the answer. Okay, so this should just work. Let's try to run this code. Yeah, so this one passed. Submit. Cool. So it passed. All right, so it's pretty interesting like DP problem, and the only difference is we don't do a DP, we don't pre-populate the DP array here like what we did before, like the n here, like the n, something like this. Okay, right? The reason being is that the key, the thing we're trying to use here is is the number itself, right? It's not the sequence basically, right? It's the number itself. That's why, because the target we're looking for is the number plus the difference, which the target could be a huge number, right? Because the difference and the number itself could be anything. So that, and when we use this target to find the previously calculated value for this target, we cannot use like the DP, we cannot use like the list here. Instead, we should use a hash table. Okay. Okay, and the space and time complexity, right? So pretty obvious, right? This time complexity is O of n, right? Because we are only looping through the the array once, and the space is also O of n, right? The length of n, because we'll be storing up to nth number in this DP hash table. Cool. I think that's pretty much it is for this problem. Yeah. And thank you so much for watching the videos, guys, and stay tuned. And yeah, I think I'll be seeing you guys soon. Yeah, time for lunch for me. All right. Bye bye.